We're working on a 2014 Hyundai Veloster 1.6 non-turbo. Customer is another shop. They've scanned it. They said it's got a P0017, which is a cam crank correlation problem. That's beyond their capability to diagnose it, so they bring it over to us, and we're gonna get to the bottom of it and figure out what's wrong. All right, we're inside this Veloster. I looked down inside here in the on the floor pan. I'm going to show you what I'm looking at here. The there's this pan here and inside the pan I've got it's like a cam sensor. Looks like a VVT solenoid and a knock sensor. And there's a crankshaft sensor. Wow, lots of parts. Lots of parts that didn't fix the problem. A P0017 is usually going to end up being a cam crank correlation issue. So those parts aren't going to fix the problem. So let's get into it. Yeah, those parts probably aren't going to fix the problem that we're going to be finding on this thing. So let's get on in the scanner, make sure that that's the only code that's in there, and then we'll go from there. What I suspect we're going to find is a cam crank is out of line. We can figure that out by lab scoping the cam and the crank together and making sure that that they're timed correctly. So should be a fairly cut and dry diagnosis, but I've said that before and got my butt kicked. So let's get the scanner hooked up to it and we'll go from there. All right, reload. That is our vehicle, and we are USA. Thing runs pretty good, but check engine lights on. So obviously there's a code stuck in there. They had already scanned it, but I want to make sure that I got the whole picture here. So we're going to scan it too. List. Yep, P0017. Crankshaft position, camshaft position, correlation. So it's calling it the exhaust code. The exhaust bank is out of line. So we'll scan them, or we'll put a lab scope on the cam and the crank and see if they line up like they're supposed to. All right, let's get under the hood, get our scopes out. All right, so I pulled up the schematic. We have our exhaust, camshaft, and crankshaft here, and I've highlighted the circuits that we're after. So the brown black and the gray black are our two circuits that we're after. All right, so we have the Pico all hooked up. I've got the red channel on the crankshaft. I have the blue channel on the intake cam, green channel on the exhaust cam. Here's my red on my crankshaft down there. You can kind of see it down there. So all those are hooked up. I got these all set up. They're on auto ranging, so we're going to start this thing up and see what we have for alignment. All right, so what we got here. Okay, our green is not working out right, so let's figure out what the heck is going on there. These are 5 volts. And let's turn the filter on that and get rid of this hash there. Okay. So, let's get that turned. All right, let's back this up a bit. All right. So our exhaust is green. And our intake is blue. So here's a known good on these on the cam cranks here. So our exhaust is blue on this one. On this example here, our intake is red and our crank is green. So if you look at the intake, the upward rise should be 1, 2, 3, 4 teeth before sync, and our upward rise should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like 16 pulses after sync. So let's see what we got here. So our blue is our intake. Let's blow this up here. So that is our sync. We are about 2.5 before there. We should be 4. So we're off a few degrees there, and then the green here, this upward rise here should be 16, and we are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We are 2 syncs late on both camshafts. So the intake is 2 teeth late, and the exhaust is 2 teeth late. There's 60 teeth, so each teeth is worth 6 degrees. So we are 12 degrees off on our cam timing. Pretty evident right there. So I just spoke to the customer on that Veloster, and he was interested in finding out exactly what was causing the cam timing to be off. And really the next step to diagnosing that thing is going to be to tear the either the valve cover off at least, or the timing cover off as well. Really the cam crank correlation on a lab scope is really just to kind of show you that it's a mechanical problem, not necessarily an oil pressure problem or a a sensor problem or something like that. So really, it's a direction to get us in the right place. But I wanted to kind of show you on the board here why it could be other things, or what other things it could be. So this is basically the setup of the timing chain on that Veloster. Super simple. It's got camshafts, and the camshafts, at the other end of the camshafts are camshaft position sensors. You got a crankshaft, and on the other end of the crankshaft is a crankshaft position sensor. So basically, those sensors are telling the computer where the cam and cranks are, not necessarily where the pulleys, the gears are. You got a guide here, you got a tensioner shoe here, and you got a tensioner and a chain. Red is the chain. So that's pretty much this whole system. So no, we were 12 degrees off on that Veloster. Where those 12 degrees could come from are several places. First of all, the chain could be stretched, which is super common. It can stretch, a quarter inch, and it's going to be off quite a bit. So chain could be stretched. That's number one. Number two is this tensioner could be weak and not allowing the shoe to push out far enough. So it allows more space for that chain to take up. It's going to make those cams retarded. Super common there. The shoe or the guide could be worn to where they're not pushing in as far as they're supposed to. That could cause the timing to be off. There's a Woodruff key or a pin maybe on the crank gear to the crankshaft. That could be worn. It gets hogged up. It doesn't get tightened down well enough. Last time it was serviced, that can sit there and walk, and it'll wear that keyway out a little bit. So basically, there's a little keyway like on the crankshaft right here. So if this was the crankshaft in here, keyway gets hogged out, and that crank gear can move a little too far. Also, these are, on this vehicle, these are phasers. So they're not fixed gears on the camshaft. They can move based on oil pressure supplied by VVT solenoids, and those will phase. They'll change the retarding or the advancing of the respective camshafts. More than likely, the problem is on ours because both camshafts were 12 degrees off. It's probably not a phaser. You're not going to have two phasers that are off the exact same amount. So it's probably not phasers. It very well could be a chain. It very well could be a tensioner. It very well could be guides, or it very well could be for a lesser extent, a keyway. It's not very common. So those are the main things it could be. I suspect it's probably a stretch chain or a tensioner or a guide. But it doesn't matter. At our shop, if it's anywhere in this system, it's getting everything. If it's got a bad guide, it's getting everything. If it's got a bad tensioner, it's getting everything. So at our shop, it doesn't matter what exactly is the problem. At the shop that we did that diagnosis for, they might want to put in just the part it needs. That's why he wanted to know exactly what part it was bad. Unable to tell him that based on the 1 hour diagnosis I had into doing a cam crank correlation. The next step would be to pull the valve cover off, put the crankshaft at top dead center, see where the chains are on the cams. That's the way that the next step would be. He didn't want to pay an extra hour diagnosis to do that, or an extra 2 hours to pull the valve cover off and do that. So we didn't go that far. If he's tearing it down to do the repair, before he takes things apart, he can decipher what exactly the problem is. So anyway, I just wanted to give you a rundown of how we figure out where that timing issue is. This is a super simple system to explain that. So there you go. Any questions, drop them in the comments, and I'll see if I can answer them. Thanks.